mag-record. Record natin. And then again, i-upload natin yung shot natin siya para dun sa mga or para sa mga na putol or biglang humihina yung connection. So again, the K is the keel of the ship. Kaya yung pinakailalim, barko natin. Okay, so GM, the metacentric height calculated by subtracting kg from km. And GM. Okay, so GM is the measure of the ship's initial stability. Okay, so again, sa sabi nga, doon tayo nagbabase kung gaano gas-stable yung barko natin. Okay, then ito yung pinagbabasehan ng ating initial stability. So BM, okay, from center of buoyancy to the metacenter. Okay, it is the metacentric radius. Okay, so between distance between the center of buoyancy and the metacenter. Okay, it is usually the radius of the circle for the movements of B at small angles of keel. So anong ibig sabihin nun? Okay, so babalik tayo rito sa ano natin. Okay, so itong nilagpasan natin na picture. Okay, so pansin natin si B as long as okay, si B or nagbabago yung ating B. Okay. So yung distance na to, usually pag tumagilid tayo, nag-tilt or nagbabago rin yung position ng ating center of buoyancy towards the bottom. Basta upright lagi yan. Okay? So, kung diretso yung ating barko, tinatawag na upright yung ating barko, itong distance na to is always equal dito sa distance ng yung magiging center of buoyancy natin, right. Ganun din kung gaano, pag itinigilid natin lalo, ganun din yung magiging distance niya rito. Okay. So yun yung ating tatawag na metacentric radius. So lahat ng angles, okay, yung distance ni metacenter to center of buoyancy, kahit na nag-shift siya, kahit nag-shift yung location ni center of buoyancy as we tilt the vessel, okay, same pa rin ang magiging distance from M or from the metacenter to our center of buoyancy. Okay, so kg, it's the height of the ship's center of gravity. That is above the keel. So yan yung distance lang ng center of gravity from the keel. So km, the height of metacenter above the keel. So km si kg plus gm or kb plus bm. Kung anong available na details natin. So kb is the height of center of buoyancy. So yung linear distance from the keel to the center of buoyancy. Take note, malagay dyan when the vessel is upright or hindi siya nakatagilid. Okay, so righting arm, so the distance between the forces of buoyancy and gravity is known as the ship's righting arm. The righting arm is a perpendicular line drawn from the center of gravity to the point of intersection on the force of buoyancy line. Okay, so balik tayo rito. Si GZ, okay, so perpendicular siya, okay, from the water line or from the G or from this line. For example, nakatagilid na yung barko natin. Ito na yung line natin from metacenter to ito na yung line from metacenter to the new center of buoyancy. Okay. Tukat tayo ng line dyan, katapat ng G na dapat perpendicular. It's not perpendicular. 90 degrees dapat yung angle. Okay. Medyo 90 degrees dapat yung angle na yan. Okay. And then yung intersection ng line na to, Saka nung new line from metacenter to center of buoyancy, it will be labeled as Z. And the line from G to Z, it is called the writing arm. Ito mismo. Yung line na yan, na perpendicular sa line ng M to B1, M to B. Okay, or yung metacenter to center of buoyancy. Okay. So that will be our tinatawag nating writing arm. Okay, so B1, shifted center of buoyancy. Okay, ito yung point dun sa bagong line. Okay? Yun yung magiging bagong center of buoyancy natin. Once na tinagilid na natin yung barko natin. Then, we have the writing moment. It is the product of the weight of the vessel or yung displacement and the writing arm. GZ. Okay? So, equal siya. Yung writing moment is equal to A. A yung ating displacement times yung GZ natin. Okay? So, ito, important terms. Pina-assignment ko sa inyo ito. Displacement is commonly used to the mass of the ship. Okay? So, take note, itong term na mass. Okay. We are using the term mass. Okay, the actual mass, kilos, in tons. Okay? Mass yun. Okay, so, kung natatandaan nyo sa physics nyo, magkaiba ang mass sa weight. Okay? Pag sinabing mass, yung mga unit to is kilo. Okay? Pag sinabing weight, i-multiply natin siya with the gravity. It will become force. Okay, so dito to be technically correct no? So we will use the term mass of the ship. So technically, it is the mass of water displaced by the ship, and when floating freely. Okay, the mass of the water displaced equals to the mass of the ship. The displacement can be presented in the curve or table where it's the function of the mean draft. Okay, so anong sinasabi rito? Okay, kung matatandaan nyo, whiteboard. Okay. So, since I'm absent or hindi ako available last week due to I had a seminar na kailangan kong attendan for the whole week. May binigyan ko kayo ng activity about the Archimedes principle or the principles of buoyancy. Okay? So, kasama na rin yun or kasama na discuss doon yung tinatawag natin displacement. And pina-assignment ko rin or pina-research ko rin sa inyo yung about sa displacement. Okay? So, in theory, any floating object, basta lumulutang sa tubig, okay, madali nating malalaman kung gaano karami or kung gaano siya kabigat without weighing it or nang hindi natin siya tinitimbang. So, paano? Ito yung rule nun sa regarding displacement. For example, okay, medyo simplihan lang natin. Okay. Kaya. Okay, so simplihan na lang tayo. For example, box na lang para mas madaling intindihin. Okay. So, and nakalutang siya sa tubig. Ayun yung ating water line. Okay. So, kung ilan yung volume nito, okay, ano yung magiging bigat ng tubig ng part niya na nakalubog sa tubig, o yung part na di-displace niya sa tubig, that will become the that is equal, that it will not become, but that is equal to the weight of the object floating on the water. Okay. So, para natin malalaman yung weight niyan. Okay. So, para natin malalaman yung weight niyan na hindi tinitimbang. Okay. We just need to know the density of the water and the dimensions nung part nung block o nung object na nakasubmerge sa tubig. For example, if okay, for example, if this submerged part is 2 meter, right? And the actual length is 10 meter, okay? And yung matitirang part dito na ano, yung width, yung lapad niya, okay? Dahil nga block yan, okay? So meron pang lapad yan doon. Okay? For example, this is 2 meters also. Ano, it should be 4 meters. Okay? So, makukuha natin yung part na nakasubmerge. We just need to look for the volume. Okay, so, ang volume natin, length times width times yung depth or yung height. This will be our length. This 10 meters will be our length. Our width will be 4 meters. And this will be our height or depth. So, depth na lang gamitin natin. So, magiging volume natin, volume ng ating submerge is equal to L times V times depth. May naglalato-lato pa yata dyan. Okay? So, yung ating length, so 10 times 4 times 2 will become 80 meter cubed. Okay? So, we have the volume. Okay? Volume pa lang meron tayo. Paano siya magiging weight? Okay? So, kailangan lang natin malaman yung density ng tubig. If the density of the density of the water is what do you call this? Is if the water is fresh water, it will have a density of 1.00 kg per meter cube. Okay? Walang equals to. Sorry. Will not have an equals. The density of fresh water, to FW. Kung salt water naman, ang density niya is equal to 1.025 kg per meter cube. Okay. So, kailangan lang natin gawin para malaman yung kanyang okay, yung kanyang weight. Okay. Kailangan lang natin i-multiply yung ating volume sa density. Kaya lang. Tama. So, kailangan natin i-multiply yung volume sa density. Okay, so yung ating mass, okay, gawin natin siya as mass equal to volume times the symbol for density is rho, Greek letter rho. So 80 meter cube. So kung at ito ay fresh water, so times 1 kg. So nasa dulo na. Kg over meter cube. So, maka-cancel yung unit ng meter cube equals 80 kg. Okay? 80 kg siya. So, guys, pagpasensyahan nyo na yung aking writing, ha. So, ganyan talaga, ano ka. So, ganun magsasolve ng displacement. Doon natin makukuha yung bigat ng object without or object na blocks, simple blocks without actually weighing the object. So, ganun din sa barko. Okay, so ang barko natin nakalutang, okay, malalaman natin yung bigat ng barko by looking at the volume displaced ng barko natin. Okay, so yun din yung principle of buoyancy. Kailangan yung buong volume, okay, ng object is, okay, yung water displaced na displaced ng object, okay, is, paano ko ba explain? Okay, so kapag inilubog mo yung buong object, yung kayang, yung, yung, yung buong water na madi-displace niya kapag inilubog mo ng buo yung object, kailangan mas mabigat yung water niya kaysa sa actual weight ng object. Kaya natin napapalutang yung ating barko. Okay? The law, that's the Archimedes principle or the principles of buoyancy. Kaya nakita nyo, yung barko natin, kahit bakal yan, is lumulutang pa rin tubig. There's no magic in there. It is purely physics or purely science. Okay. So, balik tayo sa ating PowerPoint natin. Okay. So, ito na tayo sa definition ng displacement. Okay, doon na tayo sa light ship. Sabi rito, it is the mass of the empty ship without any cargo, fuel, lube oil, ballast water, fresh and feed water in tanks, consumable stores, passengers, crew, and their effects. Okay, ibig sabihin, walang kalaman-laman. Okay, yung makina lang mismo, yung equipments niya, okay, walang tubig, walang gasolina. Okay, yung actual barko lang with its actual equipment. Okay, actual equipment yung naka-fix na talaga sa barko. Okay? Hindi yung equipment na mga or hindi yung mga tools. Okay? That is called light ship. Okay, so load displacement is the total mass of the ship when she. Okay, she dapat. We are always using the term she when we are pertaining sa mga barko natin. Okay, so it's total mass of the ship when she is floating in salt water with her summer load line at the water surface. Okay, so kung matatandaan niyo class, or kung nakakita na kayo ng barko, okay, pag nakalutang siya, okay, lagi kayong may makikitang dalawang part or dalawang kulay sa mga cargo ship natin. Okay, for example, okay, snap share ko rito. So, pakita tayo ng barko. Okay, so, wait lang class. Okay, kita ba yung screen ko class?
Ay, sir.
Okay. So, kung makikita nyo, yung naka-enlarge dyan na barko, okay, yung kanyang gilid or yung kanyang hull ay hindi lang iisang kulay. Okay, you consider the upper portion to be black and the lower portion to be red. Okay? So, yung line between them, it is called the load line or the tawag natin na summer load line. Okay? So, additional information, kaya nandyan yan, or kaya naglagay tayo ng linya na yan, it is to prevent. Okay? It will be what do you call this? It will be an indication, okay, basta lumagpas dyan sa linya na yan, sa pagitan ng red and black na yan. Okay, it is not always red and black, but that is the usual. Okay, basta lumagpas sa gitna na yan, sa pagitan ng dalawang ibang kulay niya. Okay, lumagpas na dyan yung water line, it will indicate na overloaded yung barko ninyo. Okay? That is, yun yung piniprevent, okay, ng mga the authorities ngayon. Yung pag-overload ng barko. Okay, there had been countless tragedies before. Okay, na 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 na-compromise yung stability ng barko and its structural integrity dahil masyadong overloaded or hindi kaya ng barko yung bigat na dala-dala niya. Okay? For example, yung ano ba? Forgot. Okay, itong Doña Pass. And then, okay, Princess of the Oceans, Princess of the Stars pala, Princess of the Stars, if I'm not mistaken. Yung dito sa Pilipinas, yung tumagilid. There is a case of, or there is, one of the factors ng tragedy nila is overloading. Although yung sa Doña Pass, it is due to collision, but nung inimbestigahan, aside sa collision, they are also overloaded. Okay. So, hindi man siya or hindi man nangyari yung collision, but kung laging ganun yung case ng ginagawa ng Doña Pass, okay, sooner or later it will collapse due to overloading. It will have a tragedy, another tragedy waiting to happen due to overloading. Okay, so that's why we have the International Convention on Load Lines was created. Okay, and those regulations na naglalagay tayo ng load line to prevent overloading sa barko natin. Okay, so ano pinupunto ko, balik tayo sa slide natin. Okay, so mass of the ship, kapag yung tubig or low displacement, ito yung bigat ng barko. Okay, kapag yung water line is exactly nandoon sa pagitan ng dalawang or nung ating or nasa may load line. Yung pagitan ng dalawang kulay na nakikita nyo doon sa barko na nakita ko kanina. Okay, so yun yung ating low displacement. Okay, present displacement, it is the mass of the ship at present. Ito yung talaga dyan present displacement, kung ano yung kasalukuyan na current condition or current na mass ng barko, bigat, including including all of the fuels, equipments, and people on board. Okay, yun yung ating So dead weight is the total, dead weight naman, okay, is the total mass of cargo, fuel, fresh water, etc. that the ship can carry. Ito yung when she is floating in salt water with her summer load line to water surface. Again, Okay, yung water line nandun sa ating load line or yung pinakagitna. Okay, yung pagitan ng dalawang magkaibang kulay na yun, yung load line natin. Okay, so when when at that condition, okay, ito yung total na kayang dalhin ng ating barko. Okay, except from her mass or from her own what you call this, her own weight. Yeah, so nakalagay nga rito, dead weight ng ship. So, the formula for that, the dead weight of the ship is equal to, okay, load displacement, okay, yung total load niya, total na bigat niya when the water is at the load line. Minus, i-subtract mo yung light ship or yung bigat niya barko, okay, with the equipment only. Okay, walang stores, walang fuel, walang tao sa barko. Okay, that will be the dead weight of the ship. Okay, so iba yung dead weight sa dead weight aboard. So marami tayong terms na ano, dead weight aboard, total mass ng cargo, fuel, fresh water at present. Okay, not actually at the load line, like kung ano yung present condition ng barko mo. So, meaning to say, yung magiging formula dyan, dead weight aboard or DWT aboard is equal to present displacement. Okay, minus yung light shift natin. Okay, so, okay, dead weight available is the total mass of cargo, fuel, fresh water that can be put on the ship at present to bring her summer load line to the water surface in salt water. Okay, ito yung total mass or total na bigat na kaya pa nating i-karga hanggang doon sa permissible level. Okay? Hanggang load na aabot lang hanggang sa load line. Okay? Ito pa yung kaya nating dalhin. Okay? So yung formula, dead weight available is equal to load displacement minus present displacement. And load displacement minus present displacement. Kung ilan pa yung kaya nating ikarga. Okay, so medyo information overload na, no? Mas marami pa mamaya. Okay? So, ganun talaga class. Okay, itong trim and stability. If you can see the formulas are actually simple. Napakadali ng mga formulas. Okay. But what makes trim and stability difficult is the number of formulas that you need to memorize. Okay? Simple lang yung mga calculation. Again, ulitin ko, simple lang mga calculation natin sa trim and stability. Masyado lang talagang marami. Okay? Hindi ko naman sa kayo tinatakot class, but when you take the advanced stability, advanced trim and stability, okay, mas maraming computation doon. Okay? Again, yung mga computation is simple pa rin. Simple pa rin yung mga computation doon. Okay, yun nga lang, iisang problem, but you will need to go up to 9 different formulas na kailangan niyong gawin to solve the problem. Okay, so yun. Ano lang, heads up lang. Okay. So, block coefficient, okay, or coefficient of fineness of displacement. At any draft is the ratio of underwater volume of the ship. At that draft, a rectangular box having the same extreme dimensions. Okay. So, ito yung kung ano yung, paano ko ba i-expect? Ano ba? Ito yung pagko-compare ng actual hugis ng ating barko Okay? So kung titingnan nyo, yung barko natin is not actually a block. Okay? So, yun yung natatawag ng block coefficient. Okay? From the extreme dimensions, okay, na cover yung ating barko, okay, inaano lang siya, yung actual volume ng ating barko or nung part ng nakasubmerge, i-compare dun sa actual block or yung ating rectangle or kung ating rectangular prism. Okay? So yung pagko-compare na yon, yun ang tinatawag nating block coefficient. So makukuha natin siya by getting the underwater volume or yung volume ng water na-displace, okay, from at the vessel's draft, okay, at the water line, okay, divided by the block, okay, with the same extreme dimensions, okay, yung actual block. That will be our block coefficient. So usually hindi naman natin na ang block coefficient. Usually it is already computed by our naval architects na naka-indicate na rin sa or nandun na kasama sa papers ng barko natin. So that we can know the underwater volume, our displacement at any given draft. Okay, so lahat naman siguro tayo familiar kung ano yung draft, di ba? Can I get a thumbs up if you already know kung ano yung tinatawag natin draft? Okay, so may tatlo. How about the others? Thumbs down kung hindi alam yung kung ano yung draft. Okay, so thumbs down. Okay. As long as I see thumbs down kung sige, explain natin kung ano yung draft. Okay, so wag kayong mahiya. So kaya nga tatanong ko at least para we are on the same page. Kasi yung salita ng draft dito, hindi nyo pala alam. Okay, how can we move on? Okay? Paano nyo pa maintindihan yung susunod? Okay, so since I see some thumbs down, okay, draft plus is the distance. Okay, so ipakita na lang natin kaysa ano, kasi mas madali nang nakikita. So drawing na lang tayo. Okay, for example, then pasensya na yung drawing ko klasa. Ito yung barko and then yun yung water line. Yung tinatawag natin na draft, okay, it is the distance. Okay, ito yung keel natin, yung pinakailalim, barko. Okay, it is the distance okay, from the keel, okay, mula sa pinakailalim ng barko natin hanggang sa water line. Okay, yun yung tinatawag natin na draft. Okay, yan yung spelling niya, draft or draft. Alin sa dalawa yung ang ginagamit natin na term. But most common na ginagamit natin na spelling ng draft, ayan. Okay, yung FT yung dulo. Okay. So malinaw, ano yung tinatawag natin na draft? Okay, can you give me a thumbs up? Okay, so yun. Para dun sa mga nag-thumbs down kanina, naintindihan ko ano yung draft. Okay.
Yes, sir.
So yun. So, okay, so I believe we can continue with our lesson. So, mali, sorry. Okay. So yun. So again, ating block coefficient, it is already calculated. Okay, meron ng documentation sa barko niyan. Okay, na makikita natin yung ating block coefficient at any given draft. Okay, so that we can know our displacement, gano'n ba kabigat yung barko natin on this draft. Okay? So, ayan na yan. So, volume displacement is equal to, okay, length, ito yung LB or length times spread times depth times block coefficient. That will be the volume of displacement. Okay, kung makikita nyo rito, okay, annotation. So, from this formula, okay, napunta siya rito. Okay, para malaman yung underwater volume. Kasi usually, given na si block coefficient based on the calculations na loaded na ron or pag-check ng barko, andun na computed by the naval architects na build nung or nag-design nung barko. Okay. So, ano na lang yan. Tinranspose. Okay, paano nangyari yan? So, ulitin lang natin. So, paano ba? Okay. So, both sides, multiply nito. So, for example, yung side niyan is L times D. Okay, D is draft. So, yung kabilang side din, eraser. Okay. So, kabilang side din, magkano ng L times tumatama yung ano kaya yung L times D times D. Ayan din, kabilang side. So, ngayon ito makakancel. Mangyayari, lalabas tong formula na to. Okay, simple transposition lang. Or yung manipulation of the formula. Okay, it is one of the basic skills, guys, na kailangan nyo malaman when you are dealing with calculation or formulas. Hindi yung pwede mag-stick lang kayo, dapat ganitong formula lagi. So you need to know how to transpose or how to manipulate different formulas. Ayan. So, ano na natin yan? Discuss na. Okay, water plane coefficient. So, ito block coefficient naman, water plane coefficient. Ito naman, yung water plane. Okay. So, ipakita na lang natin para mas wala. So, ito yun. So, itong water plane na to, okay, from the block coefficient kanina, okay, from the block coefficient, kinuha lang yung part na to ng ibabaw. Okay? Meaning, ito yung intersection ng the water line saka no ating barko. So, itong part lang na ibabaw na yan. Kaya tawag na water plane area. Okay? Yung tinatawag natin na water plane area. So, yun, doon lalabas yung ating water plane coefficient. Okay. Kailangan lang, i-compare lang sa actual area nung kino-compare yung actual water plane natin, itong nasa loob. Okay? Doon sa actual actual quadrilateral or yung ating rectangle kung saan nakapaloob yung ating water plane. Kino-compare lang, so coefficient. Okay, para malaman mo yung actual area nito. Again, class, it is already computed by by the neighbor architects. Okay, you just need to get the coefficient in order to get the actual water plane area at any given time. So, medyo nahuli yung picture. So, doon na tayo sa instant or important stability formulas. Okay, so dito, displacement. So, discuss ko na kanina paano malaman yung weight. Okay, so yung actual, okay, kung L, length times breadth times depth. Okay, ang aanahin natin dito, imbis na ito, it should be the volume. It should be replaced by the actual volume. Okay, so yung lalabas yung L times B times D times yung coefficient or yung block coefficient. Okay, in order to get the actual volume of the water displaced. Times the relative density, intensity ng tubig, kung fresh water or salt water. Okay, so the fresh water 1.000, and salt water is 1.025. Okay, to get the displacement ng ating barko or yung weight ng barko natin. Okay, then for the trim, we have the trimming moment. Okay, weight ng barko times or yung weight, yung weight or nung weight ng object na nilagay natin times the distance. Okay, yung D is equal to the distance from the COF. So, medyo unfamiliar term na naman to. COF means the fulcrum. Ano nga ba yung fulcrum? Okay, kung natandaan nyo, mag-draw na lang ako ng simple seesaw. Okay? Okay. Okay, so isipin nyo lang seesaw yan, di ba? Search nyo na yung drawing ko. So, yung tinatawag natin ng fulcrum. Okay, ito yung pinaka-point, gitnang point kung saan, okay, kung sa seesaw meron siyang gitna. Okay, pwedeng mag-up and down yung all this. Okay, kung saan siya nagro-rotate or saan siya umiikot. Okay, yung pinaka-gitna na to, yung tinatawag natin na COF or tinatawag na fulcrum. Fulcrum. Okay. So, yung sinasabi doon kanina, yung trimming moment, weight times distance. Clear pala kita. So, for example, ito yung barko, and you put a weight here. Okay. And kung for example, ito yung nandito yung fulcrum ng barko. Okay. Diyan, ito yung pinakagitnang point kung saan pwedeng yung parang sa siso, yung pinakita natin yung kanyang middle point. Okay. Yung distance from this, okay, yun yung ating magiging D. Distance from the center of gravity ng weight, eh, hindi naman sa actual dito lang. Kailangan sila pinakagitnang part ng object. Okay. Yung distance yan, yung magiging D natin. And then, yung W, yung tinatawag natin na weight or yung mass ng object. So, nangyari dyan, yung trimming moment, So, yun nga, yung formula equal to weight ng object 2 times distance. Okay. Yung ating trimming moment. Okay, so balik tayo sa ating PowerPoint. Okay. So again, yung area ng water plane, discuss na kanina. Length times breadth, ay yung width natin, times yung tawag doon, yung ating water plane coefficient. And then yung volume displacement natin, the length times breadth times depth or draft times block coefficient. Okay, na-discuss na kanina. So important stability formulas. Okay. So during the stable equilibrium, yung moment ng statical stability natin, so is equal to weight, okay, weight ng barko or yung ating displacement times GC ay in tons meters. Okay, yung tons meters na yan, yun yung kanyang unit. Okay, so yung GZ natin okay, is equal to GM times sine angle ng degrees. Ito yung angle ng ano natin, pagkakatagilid. So, nangyari, so moment ng ating statical stability. So, i-replace, i-ano na lang natin, pinalitan lang natin si GC. Okay? So, yung kanyang formula ni GC, ito, ipapalit lang yun doon. So, kaya nabuo si weight times GM times sine degrees. Okay, where the GC is the writing arm, yung pinakita nga natin. Yun ulit, si writing moment, displacement times GC. Yung tinatawag na writing moment. Okay, yun yung pagkuha ng writing moment. Displacement times yung GC. Okay. GC, the writing lever or writing arm, pinakita rito. So, dahil nga center of gravity, so pinakita nga natin, as the center of gravity, hindi nagbabago kahit itagilid mo. Whereas naman si center of buoyancy, once na magilid, nagbabago rin yan towards the lower part of your vessel. So, si center of gravity, pababa pa rin. Okay. And then, itutulak naman ito pataas ni center of buoyancy, resulting na babalik sa upright position. Kahit na tumagilid tayo, dahil due to external force, babalik uh, sa upright position. Okay? Or hindi siya tutuloy-tuloy na tatagilid. So, yung tatawag na writing lever or writing arm. Kaya kung mapapansin nyo yung mga bangka o yung mga barko, okay, hindi siya nagtutuloy-tuloy ng pagtagilid dahil dito sa ating tinatawag na writing lever. Okay? Once tumagilid siya, there will be a force na magtutulak sa kanya para bumalik sa dating position, or kung sumobra man, meron again sa pagkatagilid na yun, meron ulit magtutulak sa kanya para bumalik sa dating position. Okay? So, yun yung dahilan, pansin nyo, bakit kahit na tumatagilid yung barko, hindi siya nagtutuloy-tuloy. Okay, tumagilid hanggang sa tumaob. Okay, unless na yung ating G, ay or yung ating stability is unstable, in which mas mataas or nasa itaas ni GCM. Okay, kung mapunta rito sa part na yan, sa taas, okay, yung ating G, hindi lulubog o hindi basta-basta tataob ang ating barko. Okay. So, how to find the area of the water plane? Ito discuss natin kanina. Water plane lang naman is yung water plane is D. Okay, area lang ha, water plane. Length times width lang. Okay, anong oras na ba? 2:15. Okay, we're already more than ano tayo? 2:15. So I think masyado na tong information overload. Let's take a break for 15 minutes. Let's resume our class at 14:30. Okay?
Ay, sir.
Okay. So yun. So just be back before 14:30 para sa ituloy itong ating discussion.
Yes, sir.
Okay.
Right, sir.